Ever pondered why it's so crucial to understand the relationships between variables in statistics? Imagine you're trying to predict the weather. You notice when the pressure drops, rain usually follows. Here, you're identifying a relationship between two variables, atmospheric pressure and precipitation. Recognizing these relationships allows us to make educated predictions. Now, let's apply this to a more complex scenario, like healthcare. By understanding the relationship between variables such as age, lifestyle habits, and health outcomes, we can predict potential health risks and take preventative measures. In economics, relationships between variables like consumer spending and economic growth can inform policy decisions. So, whether we're predicting rain, planning health interventions, or shaping economic policies, understanding the relationships between variables in our data is absolutely vital. But there's a lingering question: how do we measure these relationships? So it's clear that understanding these relationships is key, but how do we quantify them? Enter the Pearson Correlation Coefficient. The Pearson Correlation Coefficient, often denoted by R, is a measure of the strength and direction of association between two continuous variables. Let's break this down a bit. Imagine you have two variables, say the amount of exercise you get and your overall health score. You might wonder, is there a relationship between these two? Do they move together in some way? This is where the Pearson Correlation Coefficient comes into play. It gives us a value between -1 and +1. A value of -1 indicates a perfect negative correlation. This means as one variable increases, the other decreases in a perfectly predictable manner. Think of it like a seesaw. When one side goes up, the other goes down. On the flip side, a value of +1 indicates a perfect positive correlation. This means that as one variable increases, the other also increases. They move in sync like dancers performing a perfectly choreographed routine. And then, there's zero. A Pearson Correlation Coefficient of 0 signifies no correlation. The variables are like two ships passing in the night, completely unaware of each other's movements. But remember, correlation does not imply causation. Just because two variables move together, it doesn't mean one is causing the other to move. They could just be doing the same dance to the beat of a third, unseen drummer. Now that we know what R is, how about we learn how to calculate it? Calculating R might seem daunting at first, but with a step-by-step approach, it becomes quite manageable. Let's dive into it. First things first, we need to collect our data. This data should represent two variables that we suspect might be related. For instance, let's consider the relationship between hours spent studying and test scores. Next, we calculate the mean, that's the average, for both of these variables. Simply add up all the values and then divide by the total number of values. For example, if we had 5 test scores, we'd add them all up and then divide by 5. Now, we need to calculate the deviations from the mean for each variable. This means figuring out how much each value differs from the average. If a test score was 80 and the average was 70, the deviation would be 10. Next, we square these deviations. So, in our example, 10 squared gives us 100. We do this for all the deviation values. The next step is to multiply the deviations of both variables. So if the deviation for hours studied was 2, and the deviation for test scores was 10, we'd multiply 2 by 10 to get 20. We then need to sum these products. This involves adding up all the values we just calculated when we multiplied the deviations. Now, we're almost there. We take these sums and use them to calculate R, our Pearson Correlation Coefficient. There's a formula for this. R equals the sum of the product of the deviations divided by the square root of the product of the sum of the squared deviations for each variable. And there you have it. That's how you calculate the Pearson Correlation Coefficient, but how do you interpret it? Interpreting R is just as important as calculating it. It tells us about the strength and direction of the relationship between our variables. Now, let's dive into understanding these R values. If R is close to +1, it signifies a strong positive relationship. In simple terms, as one variable increases, the other does too, like the relationship between study hours and grades. The more you study, the higher your grades are likely to be. On the other end of the spectrum, if AR is near -1, it indicates a strong negative relationship. This means as one variable goes up, the other goes down. Think about the relationship between time spent watching TV and time spent exercising. The more time you spend in front of the TV, the less time you have for exercise. What if AR is closer to 0, you ask? Well, it tells us that there's no linear relationship between the two variables. For instance, your shoe size likely has no correlation with your maths grades. Now, you may wonder what if R is somewhere in between. The closer R is to +1 or -1, the stronger the relationship. So an R of, say, 0.7 indicates a moderately strong positive relationship. And that wraps up our journey through the Pearson Correlation Coefficient. Remember, understanding relationships in statistics can unlock a world of insights. So, we've delved into the Pearson Correlation Coefficient, learned how to calculate it, and how to interpret it. We've taken a journey through the world of statistics, specifically focusing on understanding relationships between continuous variables. We've uncovered the mystery of the Pearson Correlation Coefficient, a powerful tool that helps us quantify these relationships. We've learned that this coefficient, often denoted as R, can range from -1 to +1, with each extreme indicating a perfect linear relationship, but in opposite directions. We've also gone through a step-by-step process on how to calculate this coefficient, breaking down each part so it becomes less daunting and more approachable. Finally, we've discussed how to interpret the Pearson Correlation Coefficient. We've seen how the value of R can tell us about the strength and direction of the relationship.